Welcome to Differential Equation 1 by Maxwell Dependable Reeves. Today we'll be looking at variable variable. Before we begin on variable, it is prudent enough for us to know what differential equations actually are. Differential equations are those equations that contain differential coefficients. These equations arise out of differentiations. For example, we have d of y or d of x, d2 of y or d of x2, and we have the theta or dt, d of n, y or dx of n, etc. All of these are differential equations because these equations arise out of differentiations. So we consider them as differential equations. Differential equations can be in the first order, second order, and so on. The order of differential equations can be determined the number of times differentiation have taken place. For the sake of simplicity, first order differential equations are equations that arise by differentiating once, while second order differential equations are differential equations that arise by differentiating twice, and so on. So this first equation here is an example of first order differential equation, and this is an example of second order differential equation, and so on. In the differential equation, we have two solutions. We have what we call a general or primitive solution, and we have a particular solution. A particular solution is usually obtained by giving some initial values and by solving for the constancy and replacing it into our general or primitive solution to obtain our particular solution. Let's take for example, if we have dy over dx is equal to 4. This is an example of a first order differential equation. To solve this, the first and foremost thing we need to do our variable. So to do the variable, we want to put dx one side, we put dy another side. So here we balance this by 1 and do our cross multiplication. So this times this times this. We have dy times 1, we have dy equal to here 4 dx. We have already prepared the problem for integration. We can now take our integral both sides. So taking the integral both sides, if we integrate dy, we have y to equal to 4 is a constant, so we bring 4 out. If we integrate the x, we have x. So here we have 4x plus some constant c. This solution is now referred to as what we call the primitive or general solution. So we call this solution the primitive or general solution. We can also obtain our particular solution by giving some initial point. For example, if we say y is equal to 2 and x is equal to 1. These are our initial points. For the initial point, we can use these initial points to determine our particular solution. So let's look here. So when we see y, we place 2, and when we see x, we place 1, and we can easily solve for c. So doing this, we have 2 is y is equal to 2. 2 is equal to 4 times x is 1 plus c. So here we have 2 to be equal to 4 times 1, we have 4 plus c. We can now solve for c by sending the 4 across. This 4 will change from positive to negative. So we have 2 minus 4 equal to c. You can clearly see that minus 2 equal to C. We now have the value for constant C. So we can now replace the value for C to get our particular solution. So doing this, we have y is equal to 4x plus C now is minus 2. Minus 2. So this is our particular solution. Now, so this is how we can obtain the particular solution and the general solution of a differential equation. So now let's get started. Let's start solving problem on variable cerebral. Let's see our first problem. So problem 1, we have x dy minus y, parenthesis open 1 plus x dx equal to 0. The first and foremost thing, we need to send minus y, parenthesis open 1 plus x enclosing dx across equal sign. The reason we are doing this is because we want to make our life extremely easier for ourselves in order to separate our variables. So we can send this across, the sign will change from negative to positive. So doing this, we have x dy equal to y parenthesis open 1 plus x dx. Now, we can see that it is very easier for the variables to be separated. If we have variable separation, we need to divide both sides by x and y. So here, we divide both sides by x, y, we divide both sides by x and y. We can clearly see that x will cancel x. We have dy over y to be equal to, we can also see that y cancel y. So we have 1 plus x all over x dx. Now, we can see now that our variables have been separated. The variable have been separated and make it easier for us to do our integrations. So here, we can take the integral on both sides. So taking the integral both sides, both on the left and on the right hand side. We can see that if we happen to integrate the y over y, we have a order of y equal to none. Before we integrate this second portion, we need to further simplify this to make our integration very easier. So simplifying this, we know that this x it serves as the denominator for both the 1 and also this x. So dividing x by 1 and x, we have 1 over x plus x by x divided 1 plus 1 times dx. Now, it makes our problem very easier for us to integrate now. So integrate this, you have, so here we have ln of y equal to, if we integrate 1 over x, we have ln of x plus, if we integrate 1 times dx, we got dx. So when we integrate dx, we have x plus some constant c. Now, we need to simplify this problem here or further to obtain our general solution. In order for us to determine the general solution, we need to solve for y. So we need to make y the subject to obtain our general solution. Because we are not given any initial points to find our particular solution. So solving for y, the first and foremost thing, we need to set c to be equal to ln of k, because we want to take ln of the constant in order to make life easier for us. So doing this, we have ln of y to be equal to ln of x plus x, c now is equal to ln of k plus ln of k. Now, we can send ln of x and ln of k across the equal sign and we're only left with x on the side. So doing this, we have order of y minus order of x minus order of k to be equal to x. Now, we can easily see that we have the influx of negative sign. So we can factorize the negative sign outside. So here we have order of y minus, parenthesis open, we have order of x plus order of k to be equal to x. And we can clearly see that the property of logarithms is not applicable. So since we have addition, we can multiply, and since we have a negative sign here, we can divide. So doing this, we have order of y minus, to simplify this, we have order of kx close it equal to x. Now, we have a negative sign here, so we can divide. So doing this, we have order of y or kx equal to x. Remember, in order for us to determine our general solution, we need to find y. So to find y, we can take e both sides. So taking e both sides, so we'll take e both sides now, or the order will drop. The e raised to the order of y over ks, check give us y over ks. So here we have y over kx to be equal to e to the x. We can now see that it is very easier for us to solve for y. So we balance e to the x by 1, we do our cross multiplication. We can now see that we have y to be equal to, we have kx e raised to the x. So this is our general solution. So let us look at our second problem. So in our problem 2, we can see that we first need to send positive y squared plus 4 across the equal sign. So doing this, we have e to the x dy over dx to be equal to minus y squared plus 4. Now, since we have sent a y squared plus 4 across the equal sign, we can now see how we can separate our variables. So before separating our variables, we first need to get rid of dy over dx. So here, we balance this by 1 and do our cross multiplications. So we have e to the x dy to be equal to minus y squared plus 4 times dx to get dx. Now finish getting rid of the fraction now. So we can now separate our variables. So separating variables here, we will divide both sides by e to the x and minus parenthesis open y squared plus 4. So doing this, we divide both sides by e to the x and minus parenthesis open y squared plus 4. We divide both sides by e to the x and minus parenthesis open y squared plus 4. So we can see that e to the x will cancel e to the x. We are left with minus dy over y squared plus 4 equal to, we can also see that minus y squared plus 4 will cancel minus y squared plus 4. We left with dx over e to the x. So now, the problem is very easier for us to integrate. When we reach at the point, we can take our integral both sides. So taking the integral both sides, we can see that on the left hand side, this particular integration resembles tangent inverse. So integrating this, to make life easier, we can easily say minus the integral of dy over. We can divide both sides by 4 here. Dividing both sides by 4, we have 1 plus y over 2 equals all square. So now, equal to the integral of, now the x over e to the x is the same as e to the minus x times the x. We can clearly see that it will set u to be equal to y over 2, and we use our usual notation. If we differentiate and integrate this, we'll get tangent inverse. So when we do this, it will yield us to minus 1 over 2 tangent inverse of y over 2 equal to, when we set u to be equal to minus x, and we have to differentiate, and after one differentiation, when we integrate, we'll have minus e to the minus x plus some constant c. It is advisable that before you do differential equation, you have to master your integration and differentiation, because with adding two tools, it will make life extremely cumbersome for you. So you have to practice calculus 1 and calculus 2 before watching this video. Now, we can see that negative on the left hand side will cancel negative on the right hand side. So we are left with 1 over 2 tangent inverse of y over 2 equal to e to the minus x plus some constant c. Now, remember we want to find our general solutions. So we need to simplify this problem in a way that will make y to stand by itself. So to do this, we can firstly get rid of the fraction here, which is half, by multiplying 2 both sides. So multiply both sides by 2 times 2 times 2. So doing this, we have tangent inverse of y over 2 to be equal to, we have 2 e to the minus x plus 2 constant c. But we know that our c is a constant, so we can allow for a to be equal to 2c, because c is a constant. So we'll do this. We have tangent inverse of y over 2 equal to 2 e to the minus x plus a. Now, to simplify this problem now, we know that tangent inverse of y over 2 is the same as y over 2 equal to, now we have tangent of, now, e to the minus x is the same as 1 over e to the x. So 1 times 2 gives us 2 e to the x plus a. We can easily see that it is very easier for us to make y a subject noun. So we balance this by 1 and do our cross multiplication. So we have our general solution now to be equal to y is equal to 2 tangent of, I already say open, 2 over e to the x plus a. So this is our general solution. So let us look at problem number 3. So let us see our third problem here. So here we have our 3e to the x tangent of y dx plus 1 minus e to the x minus open close it secant square of y dy equal to 0. So the first thing is that we can see that we need to transpose positive 1 minus e to the x secant square of y dy across equal sum. So when we do this, we have 3e to the x tangent of y dx equal to, we have minus 1 minus e to the x secant square of y dy. Now, all this negative affects or every value in this parenthesis. So, multiply the negative by every time the parenthesis here, we have on the side we have 3e to the x tangent of y dx to be equal to negative and positive. So negative and positive won't give off minus 1. So here we have e to the x minus 1 secant square of y dy. We can now see that it is easier for us to do our variable circle. So doing the variable circle yet, we divide both sides by tangent of y and e to the x minus 1. So we divide both sides by tangent of y and e to the x minus 1. Divide both sides by tangent of y and e to the x minus 1. So now we can see that tangent of y cancels tangent of y. We have 3e to the x or e to the x minus 1 times dx equal to e to the x minus 1 cancel e to the x minus 1. So here we have secant square of y dy or tangent of y. So the problem is now set for integration. We can now take our integral both sides. So taking the integral on the left hand side and on the right hand side, we can see that 3 is a constant, so we can bring 3 outside the integral. So we have 3, the integral of e to the x or e to the x minus 1 dx to be equal to the integral of secant square of y or tangent of y dy. Now, integrating e to the x or e to the x minus 1, we have ln of e to the x minus 1 because when we would differentiate, the bottom will get a top. So that is just one of the essence behind the use substitution in integration. So here we have 3 ln of e to the x minus 1 to be equal to, when we differentiate tangent of y, we will get secant square of y dy. So here when we do this, we have ln of tangent of y plus some constant c. We want to simplify this problem further. So therefore we can say, let c be equal to ln of k, because we want to simplify this. So doing this, we have this 3 now will come as the exponent for e to the x minus 1. So doing this, we have ln of e to the x minus 1 equals a r cube. So let's write our 3 r cube equal to, we have ln of tangent of y plus ln of k. Now, the problem is very easier for us to simplify. So we can apply the property of logarithm here. Since we are faced with addition, we can multiply tangent of y by k. So here we have ln of e to the x minus 1 equals a r cube equal to ln of, we have k tangent of y. You can see that ln on the left hand side cancel ln on the right hand side. So ln cancel ln, we have e to the x minus 1 all cube equal to k tangent of y. So here, if we want to simplify this further again, we can also solve for y. So because for y, we can divide both sides by k, because k is a constant here. So we have tangent of y to be equal to e to the x minus 1 equals to all cube all over k. But here we can also set 1 over k to be equal to a, because 1 over k is also a constant. So here we say let a be equal to 1 over k. So further 1 over k here. So here now we have tangent of y to be equal to 1 over k. Now we have a, parenthesis open, e to the x minus 1 all cube. So here we can take the inverse or the arctangent now to find y. So here we have our general solution to be equal to y to be equal to arctangent of a, parenthesis open, e to the x minus 1 equals to all cube. So this is our general solution. Thank you for your time. You can pause this video here and you keep practicing it. I strongly believe that the more you practice, the more you'll be familiar with the steps and the concept that involve. The steps and the concept are not complicated, but you just need to practice. Please share the video and please like it. Please don't subscribe. Please subscribe to this video if you like it. Please don't forget to subscribe. I love you for this. I love you most. Thank you.